Okay, algebra crazies, this is not going to be easy. First part will, then it'll get harder. So you got to really look at my structure and how I have everything organized. Some of you got to really get organized in your notes. Some of you just throw stuff down and you're not. It needs to be a little bit more organized, like a lot. All right, 10.3, operations with radical expressions. So we're going to add, subtract with like radicands, which are the square roots or the numbers underneath the radical sign. We're going to add or subtract with unlike radicands. So these are the same, square root of 2, square root of 2 to square root of 2, where these radicands aren't. Square root of 18, square root of 32, square root of 72. So they either start alike or they start unlike. This is like having 5x plus 7x minus 6x. If the radicands are the same, then you can add the numbers in front of the radicand. So these are all the same. So you have three terms. Remember, terms are separated by plus or minus signs. So you have this term, and this term. Okay? So if we have that, radicands are all the same. We can add 5 plus 7 minus 6, and we get 6 square roots of 2. That's how you simplify that. So the next one here, we have 1, 2, 3, 4 terms separated by plus or minus signs, if you remember. That's how terms are separated. And so I'm going to highlight those signs. That's how you tell how many terms you have, if you remember that. Now we have to add like terms, just like adding 6x and 2y. Can't put them together because y and x aren't the same. So we got to look for the square root of 7. We have the square root of 7, we have the square root of 7. We put those two together right here as 10 square roots of 7 plus 4 square roots of 7, so that's 14 times the square root of 7. Then we can put the square root of 11s together, those two terms, because they have the same radicand. So we put 5 square roots of 11 with negative the 6 square roots of 11, and we get 5 minus 6 is negative 1. And remember, you don't write the 1. I put it on there so I could erase it to show you don't write the negative 1. Get rid of that, please. All right, there we go. So that's a little bit better. Okay, now come over here, example 3 without the same radicand. So this is where you have to break things down, which you learned the last part, section 10.2. So 2 square roots of 18 breaks into 2 times what's 18? The highest perfect square that goes in 18 is 9. So you have 9 times 2, or the square root of 9 times the square root of 2 is the square root of 18. Okay? Then, from there, as you know, that's one term. We're going to keep breaking it down. So it breaks down to the square root of 9 is 3. So we have 2 times 3. So 2 times 3 is 6. That breaks down to that. Okay? Now we're off to the next term. The next term is 2 square roots of 32. Separated again by plus or minus signs. So here's your plus sign, here's your plus sign. So you have 3 terms again separated by plus or minus signs. So now we break down the second term. The square root of 32 can be broken down in the square root of 16. That's the highest perfect square root that will go into 32. So you got to know your perfect squares. So the square root of 16 times the square root of 2. Square root of 16 is 4. So now we can multiply 2 times 4. We get 8 times the square root of 2. Okay? That's how that breaks down. Or simplifies, in other words. Breaks down, simplifies, same thing. Square root of 72 can be rewrote as square root of 36 times the square root of 2, because 36 is the highest perfect square root that will go in the 72. And then you get 6 square roots of 2. Now we add those 3 together. Why? Because they have the same radicand. Square root of 2, square root of 2, square root of 2. So 6 plus 8 plus 6 is 20 square roots of 2 for your final answer. What if you have it this one times this one, or plus that one, not times. And so two terms. Now we want to put them together. Sorry, my thing moved on me. Move it down a little bit. So we break down the square root of 54 into the square root of 9 times the square root of 6. 9 is the highest perfect square that will go in the 54 6 times. Did I say? I don't know. Anyway, so now you have 4 times the square root of 9 times the square root of 6. Square root of 9 is 3. So 4 times 3 is 12. So you have 12 square roots of 6. That's how that breaks down or simplifies. Same thing with the square root of 24. Could be square root of 4 times square root of 6. Square root of 4 is the highest perfect square root that will go into 24. So the square root of 4 is 2. So now you have 2 times 2 is 4. And you have 4 square roots of 6. You now can put these together because the same radicand. So we add 12 plus 4 and get 16 times the square root of 6. It's like having 12x plus 4x. Same thing. Now, multiplying radicals, radical expressions. So we have 4 examples here. The first 2 are easy. The next ones become harder. So the first one is, and I think I'm zoomed in good enough. So we have 3 square roots of 2 times 2 square roots of 6. We multiply the numbers together and the radicals together. So 3 times 2 is 6. Square root of 2 times square root of 6 is square root of 12. Now we break down or simplify the square root of 12. It can be broken into the square root of 4 times the square root of 3. The square root of 4 is 2. So now we have 6 times 2 is 12. 12 square roots of 3 is your final answer. Number 6, you distribute. This times this times that. Because we have a plus sign in there. And we have 2 terms inside the parentheses. So we're going to take and distribute that first number, which is 3 square roots of 5. So we say 3 square roots of 5 times 2 square roots of 5, this times this, plus 3 square roots of 5 times 5 square roots of 3. That times that, distribute. So now we work out that. We put the numbers together, 3 times 2 gets 6. We put the radicands together, or the radicals. Square root of 5 times the square root of 5 is the square root of 25, which the square root of 25 is 5, and you have 6 times 5 is 30. That's that first term. Next term is 3 square roots of 5 times 5 square roots of 3. Put the numbers together outside the square roots. 3 times 5 is 15. And the square root of 5 times the square root of 3 is the square root of 15. So we have the square root of 15. 15 times the square root of 15. The square root of 15 cannot be broken down any further. So you just leave it like that. You cannot put these together. That'd be like 30 plus 15x. You can't put terms together if they're not like radicands or not like variables. Okay, now the next one here, we have a binomial times a binomial. We use your FOIL method. First, 4 times 4 is the first 2 terms. Then the outside 2, 4 times negative square root of 3, and I put it in parentheses. And then the inside 2 terms is the next smiley face. Remember, we have 2 smiley faces, this one and this one. Okay, a big and a little, make the O and the I. So the square root of 3 times 4. And then we have the last 2, square root of 3 times negative the square root of 3. You got to watch your negative signs. So now you should see that these 2 are the same. This is negative 4 square roots of 3, and this is positive 4 square roots of 3. It simplifies to 0. Okay? They simplify these 2 terms because remember, this is the difference of 2 squares basically. So now we have 4 times 4 is 16. And now this one is the square root of 3 times negative the square root of 3 is negative the square root of 9, which is negative 3. The square root of 9 is 3. You have a negative. So you have 16 minus 3 is 13 for your final answer. Now the next one is a little bit more complicated, a little more work to do. So we still do the first, still 2 binomials times 2 binomial, binomial times a binomial. And you do the first outside, inside, last FOIL method. So we do square root of 2 times 3 square roots of 6. Now I put it in parentheses. Plus, the outside is the square root of 2 times negative the square root of 5. And I put it in parentheses. Then you go 2 square roots of 8. The inside 2 times 3 square roots of 6. Then you do the last 2. 2 square roots of 8 times negative the square root of 5. Okay? So now you do each one of these terms. Break it down. How? Put the radicands together. Square root of 2 and square root of 6 is the square root of 12, so you have 3 square roots of 12. You break that down. 3 times the square root of 4 times the square root of 3. These 2 become the square root of 12. That's the highest perfect square, goes into 12. So square root of 4 is 2. So you have 3 times 2 times the square root of 3. 6 square root of 3 is your final answer for that term. That's the first term. Now you go to the next term. Square root of 2 times the square root of 5 is the square root of 10, and you have a negative sign, so you have negative square root of 10 all the way down, cannot be broken down. Okay, you get down to there. Next one is 2 square roots of 8 times 3 square roots of 6, so 2 times 3 is 6. Square root of 8 times the square root of 6 is the square root of 48. You now break down the square root of 48, simplifying that to the square root of 16 times the square root of 3, because 16 is the highest perfect square root that will go in the 48. So then you have 6 times the square root of 16. Well, the square root of 16 is 4. So now you have 6 times 4 is 24 times the square root of 3. That's how that one simplifies down. This one, we have 2, and we put the radicans together. The square root of 8 times the square root of 5 is the square root of 40. The square root of 40 can be rewritten as the highest perfect square root that will go into 40 is 4. 4 times 10 is 40, so the square root of 4 times the square root of 10. So this is 2 times the square root of 4 is 2. So we go 2 times the square root of 10. We get 4. 2 times 2 is 4. And now we put together the like radicans, square root of 3 and the square root of 3. So now we can add 6 plus 24 is 30 square roots of 3. Think of 6x plus 24x is 30x, or 30 and x is the square root of 3. We can put these two together because the radicans are the same as negative 1 minus 4. Negative 1 minus 4 is negative 5 square roots of 10. Think of negative y minus 4y would give you negative 5y, and the y is the square root of 10. And we're done. 11 minutes. Happy, happy.